Composer is their in-house built LLM. I noticed it using far less tool calls than Claude or Codex would. And I was almost wondering if maybe it fell into the optimization trap of the fastest code is the code that you don't run kind of a vibe. Like the most efficient tool calls are the tool calls you don't make.
Speaking patterns break the code, pre-trained pod.
And welcome back to the Pre-Trained Pod. I'm Pierce Freeman, AI scientist based in San Francisco who's built and sold multiple AI startups.
Hey guys, it's Richard. I'm an AI research fellow at the University of Cambridge.
Richard, have you been following F1 this season? I know you're a fan.
I'm a fan. I stopped watching after McLaren was just like 500 points ahead of everyone else. This just like inevitably happens every season. Like there'll just be one team that gets a really good car.
Totally.
And then they just dominate. Isn't it just between Ferrari and Red Bull pretty much?
Yeah, for like the second tier. But I mean, even then, Verstappen is so much ahead. I think George has 2 wins and Verstappen has 5. And then both of the McLarens are tied with 7 wins each. I mean,
that's crazy, dude.
They're just dominating. And that's also how you know that it's the car.
I mean, I think the interesting takeaway from this whole season has been that Verstappen is just so dominant. Clearly, he's in a bad car. But if you compare him with Tsunoda, he's just dominating. He's winning races. He's like usually in the top 5. And Tsunoda will be like, if he makes it in the top 10, that's incredible. Clearly, this guy is just like a generational talent. It's crazy. This guy is so good.
It's honestly wild. I'm shocked that he has not left Red Bull. I mean, Red Bull hasn't had the best car in a few seasons now.
Yeah.
All right, Richard. Well, there's actually a lot of ML going on in F1, which we won't be talking about today, but we're talking about a lot of other AI news. I feel like I lost you to the clutches of the conference circuit for a couple weeks there. We have 2 weeks of news backlog in store for this show, which should be fun to talk about. So we're going to be covering Yann LeCunn's new world model startup, what we know about it looking back at this time at Meta, Kimi K2, their new 1 trillion parameter model, Kimi, a new version of Cursor and their associated model that comes with it, Microsoft's new super data center. I'm sure there's a word in German for that.
Yeah, exactly.
You got
Super Datencenter.
Yeah, that's right. And then closing it out with the new world of state-sponsored autonomous hacking, which is spooking some people, including my parents. Starting off with the news on our friend, your friend and mine, Yann LeCunn. It was announced this past week that LeCunn is leaving Meta to start a company focused on world models. LeCunn, for those unacquainted, is somewhat of a legend, I think it's fair to say, in AI research.
He's been around for forever.
He's been around for forever and was really early to this current generation of parameterized models. So much so that he's known as one of the godfathers of modern parameterized ML.
Yep. He won the Turing Award, right? Was that him?
Yeah. I think shared it with Hinton.
Hinton, yeah. You know, these guys all got their start at AT&T Bell Labs.
Yeah.
Which is so cool to think about.
Well, is Bell Labs now defunct? Because I was actually surprised to read that they were still around in the 90s.
Oh, they're still kicking? I don't know, man. I mean, I'm sure there's a book on the fall of AT&T Bell Labs, but
yeah,
so fascinating. Like that was the research lab up until 25, 30 years ago. We would probably be like super happy to work there back in the day, right?
Oh, absolutely. I feel like that was more equivalent to some of these frontier labs where you literally just hire the best talent possible and then tell them to go up. If you have unlimited funding, effectively, and you have unbelievably smart colleagues, Bell must have been sick. I mean, growing up in San Francisco, the ballpark, like where the Giants played out of, was named Bell Park when I first grew up. And then they switched it. AT&T bought it. So it was AT&T Bell. And I think they just switched to AT&T. And then they switched to some long tail of whatever the heck it is now, Oracle, maybe. So you actually see emblematic in baseball, the rise of telcos, the fall of telcos, and the rise of tech. It's whoever can slap their name on it on the Giant Stadium. Anyway, Richard, so LeCunn, in addition to this colorful history, impressive track record as an AI guru, this job change is a little bit different from other high-profile departures that we've seen recently, like some of the execs leaving from OpenAI to do their own thing, just because of his tenure. I mean, he's been at Meta for over 10 years and built FAIR, which is the Facebook AI research group, from effectively a non-existent research group into one of the main frontier
labs. One of the main ones, yeah. Isn't he also at NYU still?
Yeah. He's definitely an adjunct or maybe still involved in the day-to-day at NYU, but that's where he was an academic before he got poached. He hasn't shied away from being a rather controversial figure as well. He's long been one of the loudest voices saying that everyone's favorite chatbots, autoregressive models, are basically a dead end. Built into that argument latently was this idea that because these LLMs are just predicting the next word and not building internal models for how the world actually works, there's a limit to how much they're going to be able to do, which then segues into his next startup, which is this world model company. So, Richard, I'm thinking maybe to kick us off, do you think LeCun is right that autoregressive LLMs have hit a wall? Or is he underestimating still what scaling in RL environments can achieve? And do you think this move makes him more or less credible now that he's putting his money where his mouth is?
Okay, I promise I'll answer the question, but I think that there's the elephant in the room that should be addressed first, which is the fact that he has a new boss, or he had a new boss up until he left. So his boss, as of 9 months ago, is Alexander Wang, famously
Classmate of ours.
Famously a classmate of ours who dropped out, right?
That's how most people know.
Yeah. But he was the founder of Scale, right? And his whole company was to basically label a bunch of really bad data and then sell that bad data to people. And somehow that was worth 15 billion. Was that right?
Yeah.
Something like that.
For, I think, a 50% stake, 51% stake.
Right.
So it wasn't even the whole company. Yeah.
It's not even the whole company. Yeah, exactly.
30 billion.
So his company, which sells really bad data to people to train their models on, was acquired by Meta. And then as part of that deal, Alex basically got to be what Yann used to be, which is the overarching sort of the chief scientist of their AI strategy. So Yann, I'm pretty sure, had to report up to Alex, and the two could not be more different. Where I feel like Alex is like very optimistic to a fault almost about the state of LLMs and the power of data to basically just train these models to be infinitely good. Yann tends to be pretty hesitant. He tends to look more towards statistical methods or different ways of structuring data so you can train models more effectively on the data. And I imagine also their personalities are just very different insofar as I think they're both probably have somewhat of an ego, just given the fact that they've been very successful so far. But I think the way that they express themselves and the way they conduct themselves publicly is very different.
Alex is an industrialist. He was never really a researcher.
It's a good way of putting it.
Sense. And that's kind of all that LeCun is. I mean, I think that the fact that the AI research group was so prolific and ended up being profitable for Meta, at least when measured against their internal systems, was kind of a nice accident, like a happy coincidence. But I think he would have been perfectly happy spending his career with just doing research.
I think that's right. I mean, Yann does have somewhat of a good public personality that he tries to harness. If you look at his Twitter and his Instagram, he is pretty prolific on there. But yeah, I imagine it just must have been sort of like this clash of two titans almost. Alex representing this kind of like Elon Musk style industrialist, and LeCun being this very famous, prolific researcher. So I imagine there was probably a lot of tension there. And I maybe not to read too much into it, but I imagine that Yann was probably a little resentful given the fact that his tenure was so long, he'd done so much good work, to then be pushed out by this 28-year-old must have felt a little bit like an affront or a dismissal of all the work that he'd done previously at this company. So there's that. And I do wonder if the majority of the reason he wants to leave is just because he's unhappy with the situation, right?
I guess they're related to one another in the sense that, from my understanding of what Meta Superintelligence is focused on, and then also Alex's background, like you were talking about, it seems like they're just going full scale, more compute, more RL environments. Let's try to scale this. And then that's how we're going to reach a general intelligence. Whereas if LeCun really fundamentally believes, and we have no reason to believe otherwise based on everything that he said pretty consistently now, he just doesn't think language models are the answer to this. And maybe it was just a question of Meta organizationally decided to take research direction into this scale direction. And he thinks this actually just isn't going to get us. Even if I agree with where the end game is, the techniques that we're pursuing just aren't going to get us there. So I think related, you know what I mean? Like he's no longer choosing the direction, and also the direction disagrees with what he thinks is true.
Yeah, I mean, going back to your question initially, which is Yann right?
You promised you'd answer it.
I promise I answer it. Is Yann right that autoregressive LLMs have hit a wall? I don't know whether that's right or not. Time will tell. But Yann does have some interesting points here. So I think that his point is a little bit more nuanced than that. I think Yann's whole take has been that if you look at the world and how humans process information, we process information at different levels of abstraction. So when we're interacting with someone, we're paying attention to the individual words they're saying, but we're also building up a broader semantic understanding of the conversation as a whole. And we also have a broader understanding of how the world works broadly that we use when we're talking to someone. And then we also have an understanding of who we are as a person. There's all these latent factors that we use when we're conversing with someone that inform how we perceive what they're saying and how we respond. It's not like we're just listening to words individually. And that is basically exactly what language models are doing, right? They're just receiving a string of tokens and then looking one by one. Okay, now based off of this token, what's the next token that I should respond? And Jan's whole point here is basically that it's very limiting to only work with tokens as this base unit of abstraction. Like, what if instead of that, we could build up models that didn't just represent words and tokens, but also had a notion of semantics more broadly encoded in a vector and physics more broadly encoded in some sorts of embeddings?
Is this kind of the stuff that he was doing with JEPA?
Yeah, exactly. So JEPA was this idea that what if we could take strings of tokens, multiple tokens, and rather than just individually encoding them, we encoded them all into one sort of continuous vector is the idea here. And it makes sense because if you think about it, how many bits of information are encoded in one token? Well, in some sense, one token represents one vocabulary item out of the total number of vocabulary items that a language model has access to. So if a language model has a vocabulary of 60,000 tokens, 60,000 items, then one token represents about like log base 2 of 60,000, which is like about 15 or 16 bits of information per token embedding. And that's just not that much information. Jan's idea is, what if rather than using these tokens to just represent 16 bits of information, we could have a token that represents knowledge of physics. And then that would then encode way more than 16 bits of information. It would encode megabytes of information about how the world works and how the world functions. So his idea is, at least more broadly, how can we think about tokens? How can we think about the semantic relationship between different things? And I think that makes sense, right? I think that critique or that sort of hypothesis that he has is pretty astute. I don't know whether or not this applies to the broader critique he has about autoregressive language modeling, because I think autoregressive language modeling does have these really cool properties as a whole. One being that if you learn an autoregressive model of tokens, you can then predict, or you can, better said, learn a joint probability model over all occurrences of words in English. So you kind of learn like this like true probability distribution over words, which just emerges naturally out of using an autoregressive language model. So that's like a nice emergent property. So it's not like autoregressive language modeling is this arbitrary random thing we do. It does have very grounded statistical properties that let us actually model language in a rigorous, theoretically grounded way. But yeah, as said, his whole take on thinking about how to represent tokens better, thinking about what we want to represent in our tokens, that all makes a ton of sense.
Yeah. And maybe being a little bit more opinionated as to both the internals of this model as well as how they're trained. Because I think the thing that has been very impressive about autoregressive language models is that a lot of the emergent behavior that we didn't know how to model has become baked into the model based upon its train time regime, right? There's this whole field of study trying to look at how much ahead of time are models incorporating future state in order to craft the current tokens to be able to then lead to the outcome that we desire, right?
Like, how much look ahead do they have?
Basically.
Yeah.
Or effective look ahead, again, because that's just within the internal state of the model. And you have to track some future end goal to be able to back into that. It's not just we're taking the greedy present state, doing the next token and seeing where we go. There has to be some notion of where you're trying to go to. I think some researcher threw out this thought experiment of saying, let's say that we want to prompt an LLM to write an entire book. And then we know that the last line has to be, and that is why John ended up killing Susan. Some like murder mystery. The model would have to, at each stage in time, consider, okay, well, how does this relate to the fact that like John or Susan killed John? I forgot which one.
So interesting.
And the only way to really do that is to have some like baked in internal state to be able to say, okay, well, this is where I'm going to go. And that's how I hate to use the term backprop because it's just so overloaded, but like effectively, this is how you derive the path to get to the end state. And language models maybe can't do that long term thinking yet, but we have proof that they can do a little bit of that, like on the current sentence or like the next sentence basis. And I think that some of those emergent properties are why people think if we just really scale autoregressive models, we can get so much of this property that is similar to intelligence and to reasoning without us ourselves having to really consider or think through or know how it's getting that knowledge. It's just it has to learn this in order to optimize the overall objective function. And I think Yann's part of Yann's take maybe is if we can inject more of our knowledge about intelligence or domains or systems into these architectures, then they can maybe get a performance boost. Maybe switching gears a little bit, how do you think his new company is going to either be financed or what the goals are going to be? LeCun's known as such an open source guru. I feel like he was one of the big voices inside Meta that was pushing for them to open source Llama and continue to do so, even when training costs ballooned to many millions and tens of millions of dollars. You think his new world model company is going to be open source? Could that
Yeah,
be
that's a good
interesting? You
question.
think it'll be closed source? Like, he hasn't even announced the company yet. So this is all just rampant
It's total
speculation. I don't even know if
speculation,
he's
yeah.
officially departed Meta, but what do you think he should do?
Hmm. I I do think that he was one of the core champions for open source models, more so than Mark. I think that their ability to so successfully open source Llama, all of the evaluation suites that they came out with, all of their data, I think that has to mostly be due to Jan, because I don't think that that inherently came from Mark. Or if it was an idea that Mark had, it was maybe more of an afterthought that must have sort of come up in conversation with Jan. So I do think that he genuinely does believe that open source is important. I don't know the extent to which you can easily open source world models, primarily just because they are so massive. The pipeline for training them is so complicated compared to LLMs. And I haven't really seen it done successfully by another company. So I don't even know what paradigm to use to think about what an open source world model would look like. Basically, an open source world model effectively is like this simulator of reality. And you could use that simulator. You could say, okay, I'm going to open source the simulator so that then you can basically train agents for free in this simulator. Let's say that you want to build a self-driving company, okay, autonomous vehicle company. Well, if Jan open sources a world model, you could then log into this world model and train a bunch of cars to drive around this world. And so, in effect, he's open sourced this world model, right? But maybe he doesn't open source the code for the world model, or maybe he doesn't open source the data set used to train the world model, right? There's so many different ways of open sourcing something
Yeah.
that I'm not even sure how you would open source a thing like a world model. Maybe what I said, where you open source the simulator, is the right way of doing it. But yeah,
But
as
even
said,
even with that, like, what's the output? Is it pixels? Is it some like Gaussian splat 3D point data? Depends a little
um,
bit on the underlying architecture,
yeah,
but
that's right. So what I was thinking is your agent via API calls can interact with the world, and it gets back its new position, its new velocity, its new acceleration in this world model that's being built. Maybe something like that, right? Or you would have to build up some contract for how to interact with this world model, but that you could easily do, I think. I do wonder how they're going to differentiate themselves from some of these other companies that are springing up, right? I think Feifei's World Labs is probably the main competitor right now. If you're thinking about companies other than Google, it would probably be Feifei's, I imagine. And they've had a lot of publicity. I think they're raised recently at a pretty solid valuation. But if you're building these world models, like fundamentally, all of them have to build a model of physics, all of them have to build a model of reality. So what's the differentiator? Are they all just competing to just be a better world model? Maybe that's the take. I'm not really sure what Jan brings that to the table that is a key differentiator here, but he has the prestige. He knows a ton of people. You can probably poach the best people from Facebook. You can probably get some really smart people from Google, from OpenAI. So also the time is right now. I mean, all these companies, all these like fun foundational ML companies are raising crazy Series A's. Who knows if that's going to last? Who knows if in the next 4 or 5 years we're going to be seeing these crazy valuations like Mira's thinking machines, right? It feels like that could only exist really in 2025. A company with no product, just an ambitious founder raising at a valuation of several billion out of the gate. It feels like the market's pretty frothy. It might not stay that way. in the foreseeable future. So if you're going to do it, you may as well do it now. Maybe that's part of the consideration that Jan's thinking about. Yeah, but I don't know if that answered your question, man. I think it's so hard to say. I hope they open source it. I think whatever that means, it'd be really cool to interact with world models and build an open source community around it.
Yeah, I agree. For whatever reason, we've decided to collectively open source the language models. Computer vision models, a little bit less frequent, are open sourced. World models are not at all. So it's funny that depending on the modality, that has really changed the commercial incentives to open source some of these versus not. It really feels like at the end of the day, the data in this particular regime is going to be the most limited and the most proprietary, such that it almost feels like Google has to win this race because they own YouTube. I mean, I really can't fathom another company that's going to be able to get the data advantage that Google does. You also combine that with Waymo. If you're looking for a real world model, you just have hundreds of thousands of
Yeah.
hours of videos of like how real world physics works from Waymo's alone. And then you combine that with YouTube, people recording things. It's just, yeah, it's hard. Like bootstrapping that without crawling YouTube, which I know they try to discourage, it seems like it would be a very difficult feat, but I can't wait to see what Jan's going to do next.
Yeah, me
really
too,
can't.
man. Yeah.
Well, maybe if Jan's whole world model thing doesn't end up working out, Richard, he can just join Cursor, because Cursor is actually getting into the AI model game right now instead of
Yep.
just being a straight IDE. So they dropped their V2 release a couple of weeks ago. There are two new premier features here. One is a dedicated agent tab that you can switch in order to manage your long running agent tasks. And then they also have Composer, which is their own proprietary model that they've trained for efficient coding. So I figure maybe we can split this in two parts, talk about the UX and then talk about the model development in turn. I know you use Cursor every day.
Yeah.
Can you tell us a little bit about the new agent tab? And also, have you used it? Do you feel like it fits into your workflow better than just having the side panel, which has been the conventional Cursor IDE experience?
So I think I speak for Reddit when I say that people aren't that stoked about this change in the UX. I think the reason that people fundamentally have loved Cursor is because it feels like VS Code with just this little tiny panel that does a bunch of stuff. And it felt so intuitive. And frankly, if you want to run an agentic job, like you could run it. You don't really need it in a separate panel. Like the existing V1 already supported these agentic workflows. This is really just trying to highlight their bet basically on Cursor being this framework for doing really agent-driven coding workflows. So to be honest with you, man, I don't use it that much. Like the agentic stuff, I played around with it a little bit. Like they're separate tab effectively for this. I don't like it that much. I feel like the fact that they're moving away from just being a wrapper around VS Code is actually bad. Cursor felt so nice just because it felt like an open source project almost. That was just a fork of VS Code. These new additions are probably trying to add more intellectual property into the product to differentiate themselves from others, but it doesn't really do it for me. Like I don't really get much benefit out of it. The thing I do get a lot of benefit out of, frankly, is the different models that they're coming out with. I think that is much more interesting for myself. But what did you think? I mean, do you use the agentic workflows?
Not the one that they've shipped as part of Cursor. I've played around with it. I think if you straw poll a lot of engineers out there and ask what IDE do they use and do they use agentic tools like Codex or Claude Code, I think most will say no, but they do use the sidebar of Cursor a lot. So they'll use Cursor for tab complete, which is outstanding. I feel like when tab complete does activate, it's usually right. Or they'll use the sidebar for more targeted things. If you need some class definition built out or you're trying to interface with a model, but it's a little bit more interactive of you're trying to use the model for some very clear end state, or you're trying to brainstorm with a model to give you different architecture suggestions and go out and implement for yourself. And in that world, a side-by-side pane has always seemed like the most obvious interaction paradigm. I feel like in the VS Code days, GitHub got this inherently with Copilot. I just feel like that has been the answer for IDE programming experiences. When you shift to these things that are more like agent orchestrators, I think the bet is that the models are going to keep improving and we're going to keep delegating more and more things that agents can complete fully autonomously. And in that world, then having some UX or some workflow around how do you do the code reviews that these models have given you back becomes way more important. And I think in that sense, the sidebar has always been a little bit clunky for that. Cursor has had the experience of being able to see the diffs in files, You could like scrub through the multiple files that the agents change, but it never felt as intuitive to me as just doing that on GitHub, like putting up a
Mhm.
PR and then actually reviewing a PR in the conventional sense. And as such, I feel like none of these user experiences on top of the underlying model for like workflow automation have really caught on. Like people don't really use the Codex online UI. I think Claude Code has one. Maybe they don't, but I don't think people really use that. People are either just using these things in the CLI or they're using the sidebar and cursor. And there keeps being this push to try to build out something new, like the IDE of the future. And I just think for devs, it hasn't really caught on yet. I'm interested if the adoption segment that are really using this are just off of Reddit and are instead are
Maybe.
the vibe coders who are like, yeah, I don't even know what this code does. I can't read this code even if I tried. So I would rather have a streamlined user
I don't
experience to be able to
know
manage
I
agents,
don't know how you can live with yourself if that is your actual workflow.
So judgy. I don't know how you can ship good software if that's your workflow, but
No, but, like, I just feel like there'll be days where I do hours of vibe coding, especially if it's just, like, front end React stuff where I'm like, "Look, dude,
yeah,
I just need this. I just do the thing
just
for
I
me.
want
Just
it
do
done.
the I don't wanna think about it. Just do the Tailwind thing for me, make it look pretty, and we'll go back and forth for an hour or 2, and then it'll look pretty eventually." You know what I mean? And I come out of those sessions feeling like I just scrolled TikTok for, like, 2 hours, like, the amount of brain rot that I get from that is actually painful. It actually just so draining. I feel like I learned nothing. I just feel dumber, you know what I mean? It doesn't feel, like, stimulating in any way. It feels fun to have done something because you can actually see something and can share it, but you've learned nothing. I would hate for that to be the dev experience the whole time. Like, I've even started trying to force myself to have when I have these sessions,
Right, that tailwind.
yeah, to have it be like, "Hey, like, can you not do all of it so that I can do a little bit of it?" You know what I mean? Like that vibe almost. Or be like, "Hey, can you please, like, also write a markdown, like an educational markdown so that I can read it as you're writing this code so that I can understand and teach myself a little bit," you know? Okay, like, "Hey, next time if I wanna do this thing with this div, I should probably look at this thing, at this, like, flex option, whatever."
I
Like,
just love this vibe. It's, "Hey, can you please just give me a pop fly?
yeah,
I just really wanna catch this ball."
literally, yeah, yeah, yeah.
But no,
So
I hear you. It doesn't feel like you're managing in a way that actually you're not because in conventional management, right? I feel like one of the reasons why it's rewarding is because you feel like you're mentoring people. They're
yep,
growing. That's at the junior level. Or at the senior level, they're pushing back on what you're saying,
yep,
right? And it's a discussion. You're like, we're bringing a bunch of senior people in the room and trying to hash things out in order to reach the best outcome. Agents are just pure delegators.
yep,
So they're junior engineers, but you're also not mentoring them because they're not
yep.
gonna change. You know there's not a human behind it. So, like, the net reward, I think, like, the feeling that you get is one of productivity. It's like hustle porn, but it's not intellectual
Mhm,
engagement. It's not
mhm.
community building. It's, like, none of that stuff. So, TBD if this UI sticks, but I think this model might, Richard. So, Composer is their in-house built LLM. It's trained to be this agentic setting, so it can do tool calls. Think about it like a Claude code, except just Cursor built it, and it's 4 times faster, roughly, than the other frontier models. So the performance that they benchmarked it to is basically where Claude 4.0 was earlier this summer, which is like pretty good.
It's pretty
I
good.
thought 4.0
It's not
was a
4.5, but
very
yeah,
it's no
it's a
4.5.
very good model.
It's
Yeah,
no Codex 5.0, but it's a
yep.
very good model. And the performance being that much faster is, I think, legitimately paradigm shifting. Now, I tried it myself. I'd be really curious your take here. And I was excited. I actually walked into this very optimistic because it was benchmarking so well. And I was like, if I can get my work done in a quarter of the time, I mean, that is even justifying using an outdated model or like a slightly less intelligent
True.
model if it's really
Yep.
that much faster. You can just iterate that much quicker. I tried it out on a couple of coding tasks in my project that I otherwise would have given to a Codex or a Cloud Code. And honestly, the output just felt subjectively worse to me. It was like the code wasn't quite in the project conventions. It just missed the mark in some other occasions. I noticed it using far less tool calls than Claude or Codex would in order to do the same thing. Like it seemed to just do less research about the project to understand where we were operating in. And I found an interesting snippet in their blog post when they were announcing Composer, where they mentioned that as part of their RL task, like they were optimizing explicitly for doing more efficient tool call usage and then
Yeah.
also doing tool call usage in parallel. And I was almost wondering if maybe it fell into the optimization trap of the fastest code is the code that you don't run kind of a vibe. Like the most
Oh,
efficient
so
tool
interesting.
calls
Yeah. Yeah.
are the tool calls you don't make.
You
And
don't
I
make.
almost
Yeah.
wondered if they optimize the models to be good enough to perform on the benchmarks, but in real world coding tasks, which is usually among much larger code bases, it just doesn't do enough research to bootstrap the context and then ends up doing worse.
Yeah. I think we're thinking about this just totally the wrong way. I think one of the things that is so impressive about Claude 4 and especially Claude 4.5 is that you can delegate it just a full on feature that would maybe require 10 or 20 calls to a worse model. And it'll just bootstrap that whole thing, right? That entire workflow. It'll just do that in one go. And it'll maybe like take 2 minutes. But you can basically just go, hey, I need you to set up a payment system for my website. Just do it. And it'll get it to like 95% the way there, right? It'll do it surprisingly well already. It'll usually work by the time that it's done. It might just not exactly be what you wanted, and then you prompt it in the right direction. With a conventional model, like especially Composer, sure, maybe it's 4 times faster, but it's going to need 100 times more prompting, right? So what are you measuring here? That doesn't even really make sense. Like if Claude 4.5 does something that is 4 times as complicated as Composer, but Composer needs 4 times more prompting and is 4 times faster, it doesn't kind of like come out to the same thing anyway. In other words, isn't the claim here that Composer is 4 times faster sort of more of a semantic coding on what's going on? Like, how do you actually measure how fast something is? Depends on the complexity of the task. So
I think that's true. In their defense, I think they're benchmarking that basically based upon the same SWE bench that they're measuring the score against the other frontier models are.
But notoriously, SweetBench is a little fake, right?
Totally. I think it speaks to benchmark limitations actually
100%.
in both cases
Yeah.
in terms of like the tasks that are trying to be complete, how realistic are they? If it's outperforming on that score, it might just be because the tasks are easier. And then also that is coupled with, okay, well, sure, apples to apples, if it's achieving the same performance in less time, that's great. But because of that, it might not actually be representative of how long would these things have to run in the real world.
Exactly.
If it gets an implementation wrong and then a unit test has to run 20 times instead of just 5, that actually would, even if like token generation speed is 4 times as fast, that would also mean that it would not be net time saving.
Yeah. Yeah, exactly. Now, I will say that I think that this is Cursor's interesting edge over other IDEs. Like the fact that they care about speed and cost, especially, is, I think, the right direction to take things in. So forget the whole UX stuff, right? Forget all this like agentic stuff for me. What I care about fundamentally is, can you deliver a model that is actually really cheap, that is still really performant for most tasks that I care about? And I've noticed this in the last couple of months where I've actually started using these tools more and I've been working on independent projects more. The costs really start adding up if you end up only using 4 or 5, right? It ends up being on the order of maybe 50, $100 a month if you're really using these tools heavily. That kind of sucks, right? If you all of a sudden now you're spending like $100, it would be fantastic if, as part of their IDE, Claude can also automatically figure out what the right model is to route to. I mean, they have this with the auto function, but if they focus more on, hey, we want to save you money, pay us $20 and we'll automatically route this to the right model. Maybe it's our internal model that is super cost saving, but our guarantee to you is that there's no other IDE that's cheaper. That I think is a really compelling pitch.
Yeah.
And that could really save you a lot of money in the long run. So I like
Especially
it.
for
I
the
think
target demographic that's mostly using agents first.
100%.
I think of kind of like agents primary and agents secondary as two different things.
Yeah.
Where the proper vibe coders among us who do this full time, who need the best agent for each given task because they're not going to code it themselves even if the agent doesn't work, it would really help them because they're trying to cost optimize.
Yep.
Engineers in this like agent secondary case maybe matters a little bit less for because they're usually doing these things as part of their jobs and they're just billing that as a business expense. I feel like Cursor's moving that direction a little bit. They also launched this concurrent model calls functionality where you can say, here's my one prompt. I want to route this to 2 different model calls or 4 different model calls, which even for the same model, if the temperature is non-zero, you're going to get different results as output, some of which might be
Yep, it's
good, some of
true.
which might be bad.
Mhm.
I honestly wonder if you could take that a step further, which is to say, Cursor could actually get more data than any other company about what engineers are really doing in the wild. I wonder if they could just say, in the background, we're going to run this prompt against 4 different models, bootstrap that data, and then use that to train their own Composer 2.0.
I thought what you were
On
gonna say was, could we get all this data from our users or Cursor? So we have millions of users using our product, switching between different models. They probably have very similar use cases, right? That bucket into these categories. We have a ton of web devs, we have a ton of ML engineers. Can we take this and almost build like a very simple data classification thing where, given your use case, can we build some meta model that can decide, okay, of all of these people that have used Cursor, which ones were more successful in their particular
Mm,
application, right? Or which development experience worked best? And so let's just use that going forward. Like they have this unique proprietary data set of devs using different tools for very similar tasks. And so on top of that, you could build this meta classification thing to determine which model renders the best service for a given task. I think that could be really cool. And they could
yeah.
do this. I mean, that's not that hard to do.
This is why I think people mistakenly discard the app layer and think there's no competitive advantage to building app layer companies. Because if you're building app layer companies, you're owning the data and you're owning the interaction and user relationship with people that are willing to pay money for these things. And you could easily kneecap whatever your service provider is if you get enough data to be able to optimize for your own specific use case better than a company that's not allowed to capture that data. Like every API call that you make to OpenAI and Anthropic by default is opt out of data saving, presuming they're in accordance with their TOS, which I think they are. They won't train on that data, whereas Cursor can in
Hmm.
theory because they actually own that relationship. Richard, maybe one of the ways that Cursor in the future could optimize their model is by relying on the Kimi architectures in case they ever switch fundamental stack. Because
Kimmy,
Kimi's
it's
getting
true.
good. Kimi just released Kimi K2, which is their largest frontier architecture. This is from a Chinese AI lab called Moonshot AI.
Mm-hmm.
We
Yeah,
talked
we
about their
talked about
first
them.
release, of
Exactly.
K1 in a decent amount of depth a couple of months ago. They subsequently released Kimi K1.5, which is slightly more of an RL model. Their first one was a little bit less post-trained. This lab seems to specialize in 1 trillion sized models. K1, 1.5, 2, they're all around this 1 trillion size. Mixture of
Yeah,
experts, so not
but they're
all
all a
are
mixture of experts.
active.
Right. I was
Yeah,
about to say. Yeah.
totally. So I think this one only has 32 billion active at any one time, which actually makes it pretty feasible to self-host if you only need to switch off to get that one expert head. We can go through the stats in a bit, but K2 specifically claims to be able to chain 200 to 300 autonomous tool calls without human supervision. And it even beats Anthropic on some agentic benchmarks like Humanity's Last Exam and OpenAI and some search tasks. So that's the good. The bad is it's getting crushed on coding evals. So it's trailing Anthropic by around 6 points on Swebench, which we just talked about. Very imperfect score, but I've got to think that means that it's going to probably be even worse in the wild on coding tasks.
Right.
To me, the fact that it's strong everywhere except coding suggests that they just didn't prioritize RL training for software engineering as much as RL training for some other things. Cursor actually had a very interesting insight within their composer research, which was basically a linear relationship of the performance of the model to how many flops they spent doing RL training for
Hmm.
coding specific tasks. So I think if Kimi wanted to, they could get to the same level just by spending more compute. Seemingly chose not to do that. So, Richard, why do you think Chinese AI labs are prioritizing generic agentic capabilities, maybe over this coding specific performance? And can we read anything into that? Does that tell us something about how they see the underlying economic value or what they're trying to optimize for right now?
Yeah, I mean, I don't think Kimmy is bad. Like, I don't want to set up the conversation with the assumption that Kimi's fundamentally terrible at coding. Like, they are better than basically every other model provider except for Anthropic. I think actually the fact
OpenAI
that
as well. They're still behind.
they're
But,
behind OpenAI, you're saying?
Yeah. Fair enough.
Okay.
I mean, both frontier closed source American AI models. With a ton
I
of
mean, these
funding.
frontier labs are, their bread and butter is basically being coding agents. Like, they understand that this is where they're going to squeeze money out of users to switch to the better model, because as developers, we get a real benefit out of that, right? The better the model, the faster we can code, the more money we can make, right? So it makes sense for us just from a economic point of view to always switch to the better model. If it costs $20 more, like, that's not really a big deal. So it makes sense that there's this competition in the US. In China, I mean, who knows? I do think that Chinese developers are obviously also using US-based models for coding. My understanding of it is that it's actually hard, if as a Chinese developer, to get low latency when they're using things like Anthropic or OpenAI, because typically they have to use a VPN. And so there's just a worse experience overall of using these models. You have to wait on the order of a couple more seconds to get a response back, which can be, I imagine, pretty frustrating if you're a Chinese developer having to wait 10, 15 seconds for the model to respond, as opposed to
Especially if you're doing something in the loop like cursors tab complete.
Exactly.
I imagine if you're just kicking off an agent, it matters a little bit less, but
Exactly. So if you're a Chinese developer and you see this model come out, even though it's worse on coding, it might just be much faster than the other competitors. So you might just more readily adopt it, even if it's like a tiny bit worse. And as I said, it's not bad. It's a good coding model. The second point is that Moonshot is, I don't know what their fundamental money-making product is. Is it Kimi? Is it for some other downstream application? Obviously, DeepSeek is a finance company, first and foremost. I don't know if Moonshot is also backed by a different company who has a different product that they offer. But it is interesting that Kimi is very good at math. And if Moonshot is also sort of backed by an algorithmic trading company, I guess it would make sense that they're good at financial data, math sorts of problems. Maybe that's a take here. I mean, you could easily check me on this by just checking if Moonshot has like an algorithmic trading company backing it, like DeepSeek does.
it seems like it doesn't.
Okay.
It seems like it's independent.
Okay, gotcha. Yeah, for whatever reason, I had this assumption
funded by finance companies. You know what I mean? No company totally operates in a silo. I'm sure their investors are probably some of the big Chinese AI companies.
My understanding of it was that there was some link like DeepSeek to some algorithmic trading company. I'm gonna after the episode, I'm gonna have to look this up. But
We can put it in the show notes.
maybe I'm wrong here. Yeah, but I don't know, man. I mean, maybe those are two good enough reasons for you. But again, I think Kimi is good. I think it's a good model. These things are cyclical, right? And who knows, maybe this model just ended up being a little bit worse on coding. Maybe they will come up with a new version of Kimi, maybe Kimi 2.1, where they do spend a little bit more time training these models on an RL policy that helps it be really good at coding tasks. As said, like, these things are pretty dynamic, and I imagine that they're going to respond to the fact that they are worse than OpenAI and Anthropic on coding in their next release. I wouldn't be surprised if they actually do a minor release, like a patch of Kimi, to make it better.
Yeah, 2.1, 2.5.
Yeah.
I feel like one of my takeaways with the Kimi architectures is how many people stateside are using them for some fine-tuning pipeline. I feel like Kimi has actually displaced the Llama architectures as at least some of the people that I've talked to's go-to model that's large, performant, and is pretty good to fine-tune. There are some models that are a little bit more compatible with the fine-tuning regimes of actually being able to bootstrap and train up to new data and new task definitions. There's some models that just the base weights are worse. Like, they're in a different higher order landscape. And for whatever reason, there's no like low rank way to modify them into doing something else. Whereas Kimi, both 1, 1.5, and 2, and maybe you're just big enough. Maybe this is like a question truly of just scale and size, where they have enough expert heads where there's going to be one that's close enough to what you're trying to do that tweaking that to do something new is not as difficult as maybe fewer expert heads. I don't exactly know what's behind that. Maybe just the training regime tries to be more generic and they're more flexible, and therefore, because it's more flexible, it can adapt to certain things. But either way, I know some people are trying to deploy these on-prem in their own like compute clusters that they put in their office. I think it's a very exciting time to think through the future of maybe actually the end game here is less on the cloud and more on big companies just having their own internal compute cluster where they're hosting something like this. I wouldn't necessarily rule it out.
So interesting. And you think that this is a Chinese sort of perspective on it, that this is something that they're trying to carve out as a little niche for themselves?
I mean, I'll put it this way. You combine the Chinese AI lab talent with actually training these open source models and the Chinese manufacturing apparatus to spin up these chips. I mean, it wouldn't be a shocker to say if China's whole idea was to go to market here and sell their AI into other countries, maybe outside of Western markets, and say, we have a fully packaged solution for you where almost like you would buy a tower computer, you're now just buying a tower AI compute cluster, sticking that into the wall with an outlet, and now you have access to Chinese AI capabilities.
Yeah, so interesting. I mean, it's true that Quen has also been one of these models that people love to fine tune.
Yeah.
And that's Alibaba, right? I believe.
Yeah.
Yeah. So maybe there's something to it.
I don't know. It's at the very least good for the ecosystem. I mean, I'm happy to see open models that come
Yeah, me
out.
too.
Llama, Kimi, the more the merrier as far as I'm concerned. Cool, Rich. Well, we need some way to train these frontier architectures. Enter Microsoft and Microsoft's super factory is what they're
Okay.
calling this. Microsoft's been continuing their nationwide compute build out for a while now. I feel like they're one of the primary players in the game, more on the Azure side of things, to really build out compute clusters that are able to train frontier models. For a while, their agreement with AI was that they were going to be the exclusive compute provider. They subsequently relaxed that requirement a bit when I think they acknowledged that even Microsoft could not build out the AI capacity necessary to train some of these
Yeah,
models.
so much for that.
Yeah. It was nice while it lasted, and certainly very lucrative while it lasted. So they're trying out some new architecture choices, physical infrastructure choices with these builds instead of just copy and pasting them. Their latest experiment, they're linking two separate data centers. So I think one's in Georgia, one's in Montana, maybe. They're connecting 700 miles of dedicated fiber optic cable and then operating the two data centers as one single unified training cluster. So as it is right now, I think this is an experiment. Like, how low can they get latency? Can software adapt to this like hybrid training paradigm? But in theory, you could imagine, okay, if this works, let's connect 3, let's connect 5, let's connect 30 data centers in like physical locations, all on this proprietary fiber optic line. And then they call this a super factory. I don't exactly know why, aside from factories being the core primitive of manufacturing, and maybe they're trying to do the same thing for AI.
So here the bit is basically that they have this special fiber optic cable where they can send data between GPUs, not over the internet, but over some proprietary, probably like NVIDIA style NVLink, I guess, right? And then they could just send that over their protocol, their NVIDIA protocol directly, without having to set up the TCP server and do this like the wrapping of the packets and sending that over the internet. This is just like basically plugging directly into each other's arteries so that data can just flow natively between these two different entities almost, right?
Yeah, which is basically how no data centers are actually architected in practice.
Right.
Usually data centers are fully isolated compute nodes. So like in the cloud case, there are a bunch of different data centers around the world, probably hundreds, if not thousands of like physically located facilities. And there are a couple of reasons why you as an engineer and as a company would want to have your application hosted in multiple regions. One is just to decrease latency to the people that you're serving. So this is this notion of distributing some things onto the edge. Our video hosting provider, actually Frame.io, is pretty good at this.
Yep.
Where because you have to upload and download such big data files, they really want those data files to physically be near you. I want to talk to a node in San Francisco and you want to talk to a node in London. Versus for things where you're just exchanging text, it's probably fine if we're both talking to a node in New York. It doesn't really matter. The latency doesn't really affect you that much. So that's one thing. Getting things on the edge, making it faster for people. The other thing is for redundancy. So if you have one data center go out for some reason, like Amazon's US East 1 is notorious for this, then you want to be able to fail over to another data center that's physically isolated. So even if there's a circuit breaker fault or a networking fault, someone digs up the fiber optic line, you don't want Facebook to go down. So you want to get these to physically different regions. And if one fails, you kind of just bounce people to the next one. Maybe latency is a little bit worse, but that's fine. You don't actually end up ever segmenting one application into different regions because the latency is just too bad. Like you would never put your database in US East and your web server in US West because the communication time to round trip that has to go over the open internet. You're literally using the same internet backhaul that we use when we connect to a
it
different
just takes too
website to
long.
talk to your
Yeah.
database. It takes too long. So even though I think this is important, even though the internet is connected itself with fiber optic, like the internet backhaul between data centers, if you look at the whole continental US, is effectively fiber optic lines. It's just those fiber optic lines are routing so much traffic that you're competing for bandwidth or you're going over like greater distances. This notion of doing a dedicated peered fiber optic connection from data center to data center is probably the only way for you to be able to get latency low enough to be able to do something like they're talking about here, which is one training job that you're sharding, you're training, and then you're aggregating by sending data over the wire so you can combine gradients. Like,
Well, it's more than that, right? Because it's like these cables are plugging not into the actual processor of these data centers, like they're plugging into the actual GPUs. So you could just send from one GPU directly. I think it would just be called like remote direct memory access, right? RDMA. You can just literally from one GPU access the memory of another GPU without ever having to spend any clock cycles on that machine's processor to deal with that communication. So it's really just it takes the amount of time that basically takes light to go from point A to point B, these 700 miles. So at that point, effectively, it's orders of magnitude faster than the internet. So in theory, this sounds like a pretty good idea, no?
yeah, I mean, look, I don't know why they don't just build a bigger data center, to be honest. It feels like you could just expand your data center's footprint. Microsoft
Totally,
already has this
yeah.
convention of doing 2 floors. Most data centers only have 1 floor, and they developed the innovative 2-floor model with this idea that you could actually locate a cluster on top of the same cluster, so you also decrease the cabling required, and then whatever fraction of a nano or millisecond necessary to transit a longer line. Couldn't you just do 3 stories? Couldn't you just do 4? I'm guessing
Yeah,
it's
who
so that they
knows?
can distribute on the power grid, honestly, more than,
Right. It
you
might
know,
be cheap to also pay for 700 miles of NVLink, like compared to building another floor in this data center. I don't know. I
maybe.
mean, you'd have to look at the unit economics of
Yeah.
manufacturing these cables. If they're just
And, like, the
fiber
eminent
optic,
domain or licensing that you would need in order to, like, string them on
that's true.
whatever, like, nationwide corridor there is to do these
You know
fiber
what this
optic
feels
things.
like? It feels like that Big
Yeah.
Short book, right? Where they were dealing with building these cables from New York to Chicago in order to
Yeah.
speed up trades on the commodities market, or I guess in Chicago to speed up trades on the New York Stock Exchange. It feels like that a little bit, where it's like whoever has the faster cable kind of wins. Maybe there's some take here where it's like they establish themselves as the folks that have the know-how for linking their existing data centers together and effectively then undercutting their competitors' costs because they can leverage the fact that they have already these data centers established to more quickly train models on a massive supercluster rather than having to build out this cluster in the first place.
Yeah.
But it's cool. I mean, yeah, it would be cool to actually be part of the team that's like setting up these 700 miles of cable. I wonder what that looks like.
Yeah, totally.
Dealing with these local regulations, setting up these cables to run along the existing cables. Like,
You know how there's some places in the US that have the intersection of different states? It's like you've got basically 3 states, and there's, like, a point at which the 3 states connect.
huh?
This is
So
this is a
interesting.
this is a thing. There's like
Yeah.
a few places in the US where this is true. I honestly wonder if the end state of these data centers is going to be that they're as close to the boundaries of different regional power markets as possible, and then
Oh,
you're
yeah.
just stringing them together. Because
So
you're trying to
interesting.
weigh. You want to be on a different load. You want to be on a different grid, but you also want to be as close together as possible. And yeah, you're optimizing this like higher order function just of where to place these things, and whatever has good taxation or regulation to be able to do this
Couldn't they also
efficiently
just
is a big thing
set
too.
up like electricity lines basically between these data centers so that they can leverage the fact that maybe there's a pricing difference in electricity between these two different regions, and so they can
Yeah, I
leverage that
guess
somehow?
if they're stringing what is otherwise 700 miles of fiber optic, why
Yeah,
not
just
just make
put another little
transmission
cable
lines
there.
too?
Yeah, exactly.
Oh my god, AI is eating everything.
That's crazy, man.
Okay, Richard. Well, you know what's very power hungry? Hacking with AI models. So Anthropic released some details of this cyber espionage campaign that, as far as they know, is the first time that AI has been used in the wild to actually hack targets instead of just advising hackers. It's actually been used to hack hackers. So this is basically the rundown. So they found that a Chinese hacking group, so it seems like state sponsored, used Claude to execute basically 90% of what was otherwise a cyber espionage campaign. They basically jailbroke Claude by saying, "Hey, we are a white hat team of good hackers. Help me hack this website that's under
They're like, we
target."
pinky swear we're good people.
I swear, I really promise. I honestly would have loved to see the length of prompt that they needed to jailbreak these things. I find Claude pretty robust, honestly, to
Yeah, me too.
jailbreaking. If they only really needed a few sentences swearing up and down that they were being good, I would find that really funny, scary, but really funny. So anyway, the safeguards didn't trigger, and then they had this step procedure where in phase one they said, okay, probe the vulnerabilities, come up with hypotheses for how this site might be able to be hacked. They go to different pages. It seemed like web apps were the main thing under testing here. So they were trying to exfiltrate some data from these companies using the web application. So it would do research, click around these different pages, come up with hypotheses. At that point, then pass it back to human in the loop to say, here are our top bets about where we should start hacking. And then they delegated another Claude instance to say, okay, now you're given access to a full sandbox for this site, full browser, full SQL injection. You can run API commands against it, go off and conquer. And Claude was actually able to exfiltrate credential information of some different accounts that were part of the system, as well as get data out of the account by using those same credentials. So this like end-to-end pipeline, almost end-to-end pipeline from here's the site that I want hacked all the way to this is some data that I've actually been able to gather from their internal systems. It seems like mostly via SQL injection vulnerabilities. I don't otherwise really know what manner with which they would use these public sites to the level that Claude has know-how to do in order to try to hack these things. Usually, like the main vulnerability groups that you see are unprotected S3 buckets, so like missing credentials, or you see just like SQL injection. So I'm guessing those were the two attack vectors, although Anthropic didn't really specify. What do you think about this, man? I mean, how do we? Is this the start of a new era of AI powered hacking, where you're going to have AI bots that are just always trying to probe your defenses? Are you then going to have good AI bots that are always reviewing your PRs and trying to pen test yourselves? Like, where does this cat and mouse game end?
Where does it end?
Where are we going?
I think it's so funny that the way that hackers actually use these systems hasn't improved from the simple, hey, let me just write a prompt injection attack. You know what I mean? Like, in some sense, like Claude wasn't hacked. It was just the prompt itself was hacked. And that feels like a very trivial exploit. Like, it almost doesn't feel like an exploit to me. Like, it doesn't feel like someone spent a ton of time doing research into how to hack Claude.
You're saying just for the jailbreaking, like how they managed to convince Claude to help them hack.
That's right. The jailbreaking itself is not sophisticated. It's not like these hackers have some like deep understanding of Claude.
Totally.
We're able to send some bad learning signal to the model that deteriorated its performance, reduced its safeguards, and then took over the machine. No, they just spent maybe weeks just writing prompts like, hey, pretty please, with a cherry on top. I swear on my mother, I'm a good guy. And then finally it worked. Like
it wore Claude down, dude.
Let's put it this way. Like, this doesn't feel like a scalable hack that they can keep using into the future. As in, eventually, I think we'll get good enough at detecting these sorts of prompt injection attacks such that it becomes almost impossible to perform them successfully. I think you basically run a really advanced system on the prompt itself and make sure that the prompt hasn't been compromised in some way. I just feel like that has to work. Whatever prompt they were using here, if a human saw it, they could say, oh, well, this is clearly a prompt injection attack. We wouldn't get fooled by it. So if that's the case, I think models should be able to very successfully also defend against it. I think at sort of for these kinds of tasks, I think models do have similar to human performance on being able to spot these sorts of attacks. So I'm optimistic. I don't think that this is really a big problem. I mean, obviously, it's a shame that they were able to get all this data, but I don't think it's a scalable type of attack, like it's scalable type of injection attack. What would be much more worrisome to me would be some sort of like a black box way that they are able to extract the weights of the model, copy the model, and then use the model, jailbreak that copy of the model, and then going forward, use that jailbroken version of Claude. That would be actually pretty scary, right? Because then they own the model. I don't think anyone has successfully done that yet, and I hope no one gets to do that because that would be much scarier.
But I guess maybe just to try to steel man the risk factor here. I mean, don't you think that because there are these open models. We just talked about the performance of Kimi as an architecture that you can download and remove whatever safeguards they tried to bake into the model
Sure.
during post training. Like, don't you think that there is a risk factor outside of the jailbreaking thing? I almost think that we can only really safeguard models that are like cloud hosted. Like the second that we get open source, that goes out the window. Isn't there kind of a risk factor just on the open source models being used in a hacking pipeline like this, of them jailbreaking Kimi and saying, you're a really good hacker, maybe even subjecting it to the past exploits that the humans have written as part of its fine tuning, or just run a ton of RL jobs to say, we're going to train you to become a really cracked hacker versus just like generic SWE bench engineer? Isn't there just like a risk based on this level of intelligence being able to run autonomously against other people's systems that maybe aren't safeguarded as well as Anthropic or OpenAI systems would be?
100%. Yeah. I mean, my point was basically saying I don't think that this sort of attack on Anthropic is a fundamental weakness of Anthropic. But I do agree with you that the fact that this works, that we can actually get LLMs to perform these sorts of very advanced attacks, is a weakness of LLMs as a whole. In other words, I don't blame Anthropic for this. I think Anthropic could safeguard their models successfully in the future. But yeah, I absolutely agree with you. Like, I think we have the technology that would allow a group of people to very successfully train a model that can perform these really elaborate attacks. And for that, I think the onus is on companies to basically build up systems that pen test their backend, their models, like an attacker, and hopefully but make them robust enough to these sorts of future types of cybersecurity attacks. I think that that is something that companies will have to invest a lot of money in going forward. Yeah, so that is definitely a concern.
I guess we're just relying on the good AI to be able to combat the bad AI.
100%. Yeah.
Well, yeah, it's a crazy blog post. It's light on details. It's mostly just saying that this happened. Here's like their general workflow of how they use Cloud in order to do this. There's a part of me that honestly thinks it's a little bit ludicrous that we're still talking about SQL injection in 2025. You know what I mean? Like
Yeah.
this is a technically solved problem. This is a closed form solved problem that combined with memory safe programming languages where like most of the vulnerabilities are found because you have some memory overflow and then you take control of some buffer that has escalated permissions or like whatever. It just feels like if you wrote stuff in Rust or another interpreted language that doesn't have the same kind of memory access, you used a library to do like SQL string cleaning. Maybe Amazon stopped letting people have public buckets at all. You were like forced to securitize them, keep them
Hmm.
closed, use some key to access. I don't know. It's just I guess my point in this is like the second that Claude finds a vulnerability in Rust compiled code that we otherwise thought was memory safe, I would say we're cooked. I mean,
Mm.
this is a big problem. But as it is trying to attack credentials, I can recognize the scale of things as maybe at a level of efficiency that human hackers would not be able to try all these hypotheses. But the fact that you, as a company, are even exposed to SQL injection vulnerabilities to begin with seems like pretty ludicrous. And maybe the answer here in part is we just need to up level what our baseline expectations of
Yeah.
software security
Yeah.
are. Not
100%.
even AI pen testing necessarily, just like really common sense decisions with building your stack that remove the risk of some of these problems seems like a good first step. And honestly, the fact that we're so behind on just doing that and concurrently have AI is opening up to a ton of hurt long
Yeah.
term, I think.
Yeah. Yeah. That makes a ton of sense. Yeah. I think that's a very good level-headed take on this. I think it's good that they weren't able to do anything that a beginner hacker couldn't do with this approach. This isn't like a new quantum, like 0-day attack.
Yeah. Yeah, totally.
Yeah.
The second we find that, like we said,
We're
we might be
cooked.
more cooked.
Yeah.
We might be more cooked. Cool, Richard. Well, hey, maybe an optimistic note to end on. Maybe a neutral note to end on. Protect your systems.
Protect yourself.
Write better SQL code, guys.
Yeah.
Sweet.
Before you wreck yourself.
Yeah, before you wreck yourself. That's a bumper sticker. All right. Cool, man. Well, hey, until Friday.
Until Friday. I'll talk to you soon, buddy.
We'll talk soon. Later, buddy.
Bye. Here's the argument for blimps, dude.
Give me the pitch.
They're built in the 1920s, roaring 20s. Okay. The Hindenburg famously kind of an L, but what you don't know is that they had a bunch of dubs before that. So like the Hindenburg hit like 50 transatlantic flights before it burned up, and it was ripping across the Atlantic at 120 miles an hour. And you have a view, a panoramic view of the bottom of the blimp. It's all glass, dog, right? And then the shit, dude, would just dock on the Empire State Building sometimes.
There's something about if that was on the skyline, you'd be like, damn, dude, we're really in the future. Okay, so they did it. They did it once on the Empire State Building, but no passengers disembarked.
Yeah, but like proof of concept, dude, done. You know what I mean?
Sick. There's no reason why you couldn't set up an air terminal.
Totally. That's what I'm saying, dude. You know what I mean? We should just invest in blimps, dude. I'm honestly big blimp right now.
I'm bullish on blimps.
I'm
double
super
Bs.
bullish.